Friends, very good morning to everyone. Today's subject of presentation is Debus Radzisewski's imidazole synthesis. This is a process or a method for the synthesis of imidazole ring system given by Debus and Radzisewski. Thus, this is named after them. What is this Debus Radzisewski synthesis? Here, this is a multi-component reaction which is given for the synthesis of imidazoles. In this, 1,2-dicarbonyl compounds are treated with aldehyde and ammonia or a primary amine to give imidazole. This is a versatile method which has been utilized for the commercial synthesis of many types of imidazoles. This reaction occurs in two steps. As there are dicarbonyl compound, aldehyde and ammonia. In the first step, the dicarbonyl compound 2,3 diketone, if I take, or COCOR. The R may be two different alkyl or aryl groups. The 1,2-dicarbonyl compounds condenses with ammonia to give rise to diimine. Ammonia reacts with the carbonyl carbon. There are lone pair of electrons on the nitrogen of ammonia. And this lone pair because of this lone pair of electrons is electron rich. The carbonyl carbon is electron deficient due to the fact that it has electron withdrawing group attached to it. This is a positive center and is an electron rich center. As we know, unlike poles attract each other. The lone pair of electrons attacks on the carbonyl carbon and forms a bond. Once it forms a bond, the carbon becomes pentavalent, which is again unstable. To maintain its stability, the pi electrons in the carbonyl carbon shift towards oxygen and it becomes O minus. It combines with H plus from the reaction medium and it gets converted into OH. 2 moles of ammonia are utilized for 1 mole of dicarbonyl compound. The second ammonia will react with the second carbonyl carbon. Similarly, the pi electron shifts on the oxygen and it becomes OH. The carbon-nitrogen bond is formed. And the carbonyl group got converted into corresponding alcoholic group. The reaction do not stop over here. The nitrogen-hydrogen bond breaks. Electrons moves towards the carbon and OH gets kicked off. This OH kicks off as OH minus, which combines with this proton. H plus and OH minus lose as water molecule. Similarly, in the second position, nitrogen, here also the same thing occurs. OH gets kicked off and it loses water molecule to give rise to a diimine. The carbonyl group in the starting material has been replaced by this imine, which is formed, again reacts with aldehyde or ketone. Diimine reacts with an aldehyde. The pi electrons between the carbon hydrogen nitrogen moves towards nitrogen. Once the electrons moves towards nitrogen, what happens to nitrogen? It becomes electron rich. In the aldehydic group, the carbonyl carbon is electron deficient. As this electron deficient center and a rich center reaction occurs, the carbon has to maintain its tetravalency. That's why pi electrons moves onto oxygen, and it gives rise to corresponding compound in which the carbon and nitrogen bond is formed, and the carbonyl group has got converted into alcoholic group. Then again, as these electrons are moved towards the nitrogen, this carbon has become positive. It is unstable. To regain its stability, the nitrogen hydrogen bond breaks and this loses as H plus, and the bond form, thus excess electron are shared with this positive center. Further, the pi electrons over here moves towards the nitrogen, creating a negative center, electron rich center, which attacks on the carbon, and OH gets kicked off, giving rise to corresponding imidazole derivative. This is a positive center. The pi electrons over here moves towards this positive center to satisfy the positivity of this carbon. Once this electrons moves, the nitrogen become electron deficient. Thus, to satisfy this electron deficiency of nitrogen, carbon-hydrogen bond breaks and electrons moves towards nitrogen, and aromatization has occurred to give imidazole. This is the process of synthesis of imidazole given by Debus and Radzisewski. If at all I replace one equivalent of ammonia, in the first step I treated with two equivalent of ammonia, right? If I replace this ammonia by amine, then it gives corresponding n substituted imidazoles in quantitative yields. Like this. I'll get the NH as substituted. Instead of free NH, it is substituted. And this reaction takes place in the presence of acid, like HCl. This reaction is applied for the synthesis of n number of derivatives of 1,3-dialkyl imidazolium ionic liquids. This is the application of this Debus Radzisewski imidazole synthesis. Next class we can deal with other synthesis. Till then, have a nice day. Thank you.